Now, once again, all the guys and the girls of class 11th. Now we are going to see some questions. Here, see question number first. Threshold frequency is. This question is related to what? Photoelectric effect that was investigated by Einstein. Now see, in threshold frequency is what? Same for all metals, different for each metal, and none. Here see, threshold frequency is intensive property, that's why it is different for each metal. Now we are coming to question number second. Orbital is derived from, this thing should be known to you, orbital is derived from magnetic quantum number. Now question number 3, Zeeman effect is a splitting of spectral lines in magnetic field. So option A is correct over here. Now see question number 4, the number of nodal planes in forest subshell is. See what is nodal plane? Nodal plane means where electron is not found, or better say electron density is 0. Electron density is 0. This point is called nodal point. So actually if you want to calculate the nodal point in s orbitals, then what is the formula? N minus 1. So what we are going to get here, the value of n is 4. 4 minus 1 is equal to 3. There are 3 nodal points in forest. So option A is your correct option. Now see question number 5. Absorption spectra has, this thing is known to you perhaps, this is dark and bright bands. Now coming to question number 6 here, that is 2D orbital possible? So the answer is very clear, no. 2D orbital is not possible, because suppose if you are talking n, taking n is equal to 2, then here the value of L is what? N minus 1. Accordingly 2 minus 1 is equal to 1. Okay, and 0 stands for S and 1 stands for P. That's why this D or 2D orbital is not possible. The size of ions, see here, in order to find the size of ions, we should be very careful in choosing the option. K plus is larger in size than Na, and Na is larger in size in comparison to Na plus. On the what I can say here, the variation we for choosing the answer is down the group ionic size increases. This is one thing, and parent atom is larger in size in comparison to cation. So under this thing, if you see the answer B is your correct option. Which is the most reactive metal? So if you move down the group, what happen? Ionization potential decreases, and reactivity of metal is inversely proportional to ionization potential. So what we can say, if we go down the group, then reactivity of metal increases. Then here potassium is what? Your correct answer. Now coming to question number 9, which is the most reactive non-metal? So this thing depends upon, for non-metal, the thing depends upon what? The thing depends upon electron gain enthalpy, and the relation is what? Reactivity is directly proportional to what? Reactivity is directly proportional to electron gain enthalpy. More the electron gain enthalpy, more will be the reactivity. Here see, due to interionic repulsions, fluorine does not have more electron gain enthalpy. The maximum electron gain enthalpy is for chlorine molecule, and that's why chlorine is the most reactive non-metal. So for question number 9, option B is correct. The second electron gain enthalpy is, so what happens when one electron is received by the atom becomes negatively charged, and when atom becomes negatively charged, the electrical field around the ion becomes negative. Here we have negative electrical field. When electron tries to come over here, then the force of repulsion operates, and we have to introduce the electron by supplying the energy. That's why for option 10, the answer B is correct. See question number 11, the bivalent metal. Here it is somewhat big question and of 5 marks. A bivalent metal has the equivalent weight of 12. Calculate the molecular weight of its oxide. So as the metal is bivalent, suppose we are taking it to be M, and as it is bivalent, so formula of oxide will be MO. So the atomic mass we can calculate by what way? Equivalent weight into valency. The 12 into 2 is equal to 24 and plus here 16. The total goes to 40. So 40 gram is correct answer. If your answer is 40 gram, you should be given 5 marks. See here, calculate the ratio of energy of a photon. See here, calculate the ratio of energy of the photons of wavelengths 3000 angstrom and 6000 angstrom. So you know, for energy here one formula is there, H into nu. If you want to replace this nu, we have to apply the wave formula. So wave formula was C is equal to nu into lambda. Okay, if you want to get the expression for what I can say, for the expression of nu, then we'll get what? Nu is equal to E, and here divided by what? For nu we are going to put the value, then C upon lambda. So E will be equal to HC upon lambda. That is what we are going to get for E1 and for E2. So here the relation is what? The relation is indirect. That's why the ratio we will get will be 2:1. That will be the answer. And if you have done this question in proper way, your marks will be 5. Threshold frequency of a metal is 5 into 10 to the power minus 13 second, upon which 1 into 10 to the power 14 second frequency light is focused. Calculate the kinetic energy of the emitted light. Here see the concept is, this question is directly taken from photoelectric effect. Here same H nu minus H not nu. This is your what I can say, this is your wave function, threshold frequency. This is threshold frequency, and here the value will be half mv square, or simply we can say kinetic energy. So if you want to calculate the kinetic energy, here we will take H and nu minus nu naught. Here kinetic energy. Now put the value here and you will get the answer. So if you have done in this way, then surely your marks would have been given to you 5 marks here. Now see, for question number 14, the second ionization enthalpy of a bivalent atom is always greater than first electron gain enthalpy. Why? See here, the second ionization enthalpy, actually we have to understand that why energy is needed. Actually, nuclear charge operates on the last electron and it supplies its centripetal force so that it rotates around it. If we want to take it out, we have to supply the energy, and that energy is called IP. When the nuclear charge will increase, then the value of IP will increase. When one electron is lost, suppose we are talking about sodium, then its impressive nuclear charge is +1. After losing one electron, the impressive nuclear charge will be 2+, and that's why electron will feel a strong force and more energy will be required to remove this electron. That is the proper answer of question number 14, section A. Now see section B. Why is it that electron gain enthalpy is a dominant term for the chemistry of non-metals? Actually the answer requires some long discussion. See, actually when we are going to non-metallic groups, then what happens? The nuclear charge increases. Nuclear charge increases, and when nuclear charge increases, what happens? Outside the atom, suppose atom is represented by this circle, then outside the atom, what happens? Here positive electrical field appears, and due to this positive electrical field, electrons are dragged, or they feel attraction, and they get inside the atom. And that's why for non-metal, electron gain enthalpy is a dominant term. For this, you have to discuss this concept, and what that concept is, the concept of high nuclear charge. Thank you. Have a nice studies day.